It's easy to overlook just how much physics there is in everyday things. I mean, physics is everywhere. And since you're here watching this video, I'm guessing you like physics. But do you know what? I bet there's a good chance that you have some misconceptions about it too. For instance, if I asked you to name a situation where friction was important, what would you say? Roads, sports, walking, maybe chairs. All of these are good examples. And yet all of them are also examples of sliding friction. But what about other types of friction? How many of those can you name? Static or rolling friction. Do you know what they are? Do you know when they come into play? Let's explore this together, because who knows? Maybe you already know more than you think. First off, let's get back to basics. Friction is a force that opposes motion. It always acts in the opposite direction to the applied force, which means that it tries to prevent an object from moving or keep it at rest or stop it from speeding up. Now the coefficient of friction tells us how strong the frictional force is for a given applied force. The higher the coefficient, the higher the friction. And we often think of friction as something bad, something to be avoided because, well, it causes wear and tear. It makes things hot, it wastes energy. And frictionless environments are great, at least theoretically, because that way you could slide down a hill forever. Rollerblade around the world, never having to retie your shoes. Okay, probably not such a great idea after all, but at least you wouldn't have to retie your shoes. But what if friction wasn't all bad? What if it could make your life easier? Think about it. In order for friction to cause problems, you need to overcome it. For instance, if you want to push a box across the floor, you need to apply enough force to overcome the static friction between the box and the floor. If you don't apply enough force, the box doesn't move. Static friction is the friction that prevents an object from moving when at rest. This value depends on the type of surfaces in contact, their roughness, their temperatures, and most importantly, the normal force pressing them against each other. Normal force is the force exerted by a surface that is perpendicular to the object. In our example, the normal force is the force exerted by the floor on the box. So if you manage to push the box past the initial static friction, it starts moving, and now kinetic friction kicks in. Kinetic friction is the friction that acts on a moving object. Usually it's lower than static friction, but still, if you want to keep the box moving at a constant speed, you still have to apply a force equal to the kinetic friction. So in both cases you have to put in work. But now imagine that instead of pushing a box, you're rolling a wheel across the floor. You know wheels are basically circles, right? Well, that means that instead of sliding friction, we have rolling friction. Rolling friction is friction that occurs when a wheel or a ball rolls over a surface. This type of friction is typically less than both static and kinetic friction. And so to roll a wheel, you need to apply a smaller force than to slide a box of the same mass. That's where friction actually helps us. We use rolling friction in everyday situations all the time. A ball rolling on the ground, a car driving on the road, a bicycle moving forward, even Earth spinning on its axis. All of these phenomena are made possible because rolling friction is lower than sliding friction. Okay, but let's go back to the ball rolling on the ground. You kick the ball and it starts rolling with a certain speed. Eventually it stops because of friction with the air and the ground. But you know what? Friction also slows down the air molecules as they collide with the ball. That's why the air molecules that are close to the surface of the ball slow down faster than those farther away from the surface. The result is a temperature gradient with hotter air near the center of the ball and colder air on the surface. This temperature difference generates currents in the air, and the currents redistribute heat through convection. So in this case, friction actually generates heat, which is what happens in a lot of machines, like car engines. In fact, friction is so useful that without it, our lives would be pretty difficult. Think about it. Friction allows us to walk, run, jump, and even breathe. And that's thanks to the friction between our feet and the ground, and the friction in our lungs as air moves in and out. But friction isn't just about movement. It also plays a crucial role in keeping us upright and stable. When we stand on the ground, friction between our feet and the ground prevents us from slipping. And when we're in a car, friction between the tires and the road keeps the car from skidding. Without friction, it would be impossible to drive safely. Period. Not only that, but friction helps us manipulate objects. Take a screw, for instance. You can tighten it using a screwdriver because of the friction between the screw and the wall of the hole. Without friction, the screw would simply spin without moving forward. The same goes for nails and glue. The reason glue holds things together is partly due to friction. And speaking of holding things, friction is key to gripping things with our fingers. The tiny grooves on our fingertips dig into the surface of an object, increasing the coefficient of friction and allowing us to hold on to it more securely. And when we get sweaty or wet, our grip becomes weaker because water reduces the coefficient of friction. Even our ability to hear depends on friction. When sound waves travel through the air, they cause the air molecules to vibrate. These vibrations then cause the tiny hairs in our ears to vibrate as well. But these hairs can only vibrate because of the friction between them and the fluid inside our ears. Without friction, the fluid would simply compress and expand without vibrating, and we wouldn't be able to perceive any sound. You may think that friction is a nuisance, but it's really one of the forces that makes life on Earth possible. And I haven't even told you about the weirdest friction there is, superfriction. Superfriction is an extremely strong form of friction that occurs when two surfaces are pressed against each other with a very high force. This force is so strong that it literally welds the two surfaces together. It doesn't matter what type of surfaces we're talking about, be it metal, ceramic, or even biological tissue. Under extreme pressure, they all become welded together as if they were one single piece. This effect is widely used in manufacturing processes such as friction welding, which joins two metals by rubbing them against each other at high speed. It's also used in powder metallurgy, where metal powders are pressed together under high pressure to form solid components without the need for any melting. The resulting components have unique properties and can be made into parts with complex shapes that would be difficult to manufacture using traditional methods. There are many other examples of superfriction in action. You can find it in the tips of mountaineering gear that stick to rock faces, in the adhesives that bond together different materials, and in the brakes that slow down trains and airplanes. You can even find it in nature, where superfriction helps tiny insects cling to vertical surfaces and allows lizards to walk on water. Superfriction might sound like science fiction, but it's real and it's all around us. This strange phenomenon is an essential part of our everyday lives, enabling us to do things that would otherwise be impossible. And yet we usually take it for granted. So next time you see a ball rolling on the ground, a car driving down the street, or even a screw in a wall, take a moment to appreciate the amazing physics that makes it possible. And remember that friction isn't always a bad thing. Sometimes it's the only thing that keeps us from slipping, sliding, and skidding all over the place. And it's not just friction that makes our world go round. There's so much more amazing physics happening all around us that we often take for granted. If you want to learn more about the hidden physics of everyday life, stay tuned for more videos. Now I'll leave you with another video that talks about something that has nothing to do with physics, but it's still awesome: how chocolate is made. Hey there, welcome to my channel. Today, we're going to talk about friction. What is friction? Friction is an interaction that resists the relative motion of two surfaces in contact. There are many types of friction, but they all have one thing in common: they oppose motion. Friction is a force that opposes motion. It always acts in the opposite direction to the motion, or the direction of intended motion. Let's take a look at a few examples of friction in our everyday lives. If you want to push a box across the floor, you will need to apply a force greater than the force of friction between the box and the floor. Once the box is in motion, friction will continue to oppose the motion until the box comes to a stop. The force of friction depends on the nature of the two surfaces in contact. For example, it is easier to push a box across a smooth wooden floor than a rough concrete floor, because the force of friction is less on the smooth surface. When you walk, your feet exert a force on the ground, and the ground exerts an equal and opposite force on your feet. This force is what allows you to move forward. If there were no friction between your feet and the ground, you would not be able to walk. In fact, you wouldn't even be able to stand up. You would just keep sliding around. Friction is also what allows us to use